Welcome back. Today, we're stepping onto the factory floor. But hey, this isn't your grandfather's factory, all grease, noise, and gears. We're talking about smart factories, places that are becoming truly intelligent, capable of thinking, adapting, and even predicting what's going to happen next. So how on earth are they doing it? Well, let's get into it. Just think about this for a second. What if a factory could warn you that a machine is about to break down, days before it actually happens? Or what if it could spot a tiny, microscopic flaw in a product that no human eye could ever hope to catch? I mean, what if a factory could literally predict its own future? This isn't some sci-fi movie glot anymore. It's the very real power of machine learning. So, what is this stuff really? Machine learning, or ML for short. The simplest way to think about it is this. Instead of a programmer trying to write a million if this then that rules for every possible situation, which is, impossible, you just feed a ton of raw data into a smart algorithm. The system looks at all the examples and starts to figure out the patterns all on its own. It actually learns how to do its job, which is pretty wild when you think about it. Okay, so let's dive into our first section, smarter factories. Here, we're going to unpack exactly what ML is doing on the factory floor and, more importantly, why it's such a massive game changer for manufacturing today. Think about the really tough, mind-numbing, and repetitive jobs in a factory. Well, machine learning is stepping in to automate the kind of tasks that used to need a highly trained human expert. We're talking about things like spotting microscopic cracks on a circuit board or perfectly grading the quality of thousands of products rolling off the line. And this isn't just about making life easier, it's about creating a serious competitive advantage. And check this out. It's not just about making things a little bit better, it's about making them measurably better. I mean, look at these key metrics. You see fewer defects in your products, which is huge. You get way less downtime from broken machines, and your overall yield, basically how much good stuff you make, goes up. So the takeaway here is simple. This tech delivers results you can actually see on the bottom line. But how does a machine actually learn to do all this? Is it just one magic algorithm? Well, no. It turns out it's not a one-size-fits-all kind of deal. So let's explore that in our next section, where we'll look at the three main ways a machine can learn. Okay, so here are the three main flavors of ML. First up, you've got supervised learning. This is like training a new employee by showing them a bunch of pictures and saying, see this? That's a defect. That one? Nope, that's good. You give it examples with all the correct answers already labeled. Then there's unsupervised learning. For this one, you just dump a giant pile of data on the machine, say a ton of readings from different sensors, and you tell it, go find what's interesting. It discovers hidden patterns all by itself, which is perfect for spotting when something just isn't right. And finally, we have reinforcement learning. This is like teaching a machine to play a video game. It tries stuff, gets points for good moves, loses points for bad ones, and over time, it figures out the best strategy to win. This is amazing for really complex problems, like figuring out the perfect production schedule. Now, it doesn't matter if it's supervised, unsupervised, or reinforcement learning. All three of these styles have one thing in common. They are all incredibly hungry for one key ingredient. And that brings us right to section 3, the data-driven recipe. You see, building a great ML model is kind of like baking a cake. You have to follow the recipe. And it all starts with step 1, quality data. Because you know the old saying, garbage in, garbage out. Then, step 2 is all about pulling out the most useful signals from all that raw information. And finally, for supervised learning, you have step 3, applying accurate labels. And this part is absolutely crucial. And hey, don't just take my word for it. This quote from our source material really hits the nail on the head. Inconsistent annotations degrade supervised performance. What does that mean in plain English? Well, if the correct answers you're feeding the model are messy, like if one human inspector calls a tiny scratch a defect, but another one calls it okay, then your model's going to be messy and unreliable too. The quality of your training data determines everything, period. All right, we've covered the what, the why, and the how. Now for the really fun part. Let's get into section 4 and see what this all looks like when you put machine learning to work on a real assembly line. So first up is predictive maintenance. Instead of just waiting around for a critical machine to suddenly break and shut down the entire factory, which is a nightmare, by the way, ML can analyze its performance data over time and predict its remaining useful life. It's basically a crystal ball that tells you something's about to fail before it happens, saving you from those incredibly expensive, unexpected shutdowns. Next, let's talk about visual quality inspection. This is where ML basically gets superhuman vision. It uses something called a convolutional neural network, which is a fancy way of saying it's an algorithm inspired by how our own brains process images, to learn how to see defects that are totally invisible to a person. And the really clever part? Thanks to a technique called transfer learning, it can get good at this even if you don't have a million pictures of defects to train it on. Then there's process optimization. Remember that reinforcement learning we talked about? This is where it really shines. The algorithm basically becomes the ultimate factory manager. It's constantly running simulations to figure out the absolute best schedule for every job and every machine. And it can adapt on the fly if something changes, cutting down completion times and making sure the whole place runs like a well-oiled machine. And last, but definitely not least, something we can't forget about: security. A smart factory is a connected factory, right? And that means it's a potential target for cyber attacks. Here, ML acts as a digital guard dog, constantly monitoring everything on the network to spot any weird or hostile activity, making sure the entire operation stays safe, secure, and reliable. So, after seeing all that in action, let's zoom out for the big picture. It's time to wrap things up with our final section: the future of manufacturing. If you take away just one thing from all of this, let it be this simple but really powerful idea. Machine learning's real job is to take these mountains of raw, messy data, sensor readings, production logs, quality control images, you name it, and transform it all into clear, actionable intelligence that you can actually use. So really, this isn't just about getting machines to do what we already do, only faster. It's about unlocking a whole new level of insight and efficiency that was just never possible before. And that leaves us with one final big question to chew on. As this technology gets smarter and smarter, what's the next human task that machines are going to learn?